Welcome to a lesson with Dr. Powell. Let's take a look at how we can think about exponents and fractions of exponents and how we can play with that a little bit. So, for instance, first of all, 2 times 2 times 2. We know we can rewrite that as 2 cubed. What does this 3 mean? It means how many ideas we have of multiplying by 2 in an expression. All right, what if we had something like 2 to the 1/5? That means 1/5 of an idea of having a multiplication by 2 in an expression. Well, what would happen if we had 5 of those ideas? So 2 to the 5th times 2 to the 5th times 2 to the 5th. So we have a fifth of an idea, and then another fifth idea, and so forth. Well, that makes a total of 1 idea, right? The ideas add together that way. All right. So if we have a fifth of an idea, a fifth, they will make 2. Often we say that's the number that we denote as the 5th root of 2. What number times itself 5 times will give you 2? That's the beauty of exponents. What it does is it's turned the multiplication that we have down here into an addition of ideas. So how many 2s, the idea of how many 2s we have in an expression is now can be written this way, and we can have fractional things. I mean, it's easy to see when it's whole numbers, right? The idea of having 3 2s in a multiplication expression, 2 cubed. But when we have a fifth, it kind of goes backwards, if you will, in the idea a little bit. But you have 2 to the 5th times 2 to the 5th and so forth until you get 2 to the 1st. All right. Now, what if we have something like 2 to the -3? What in the world does that mean when I have a negative exponent? That simply means that we are, it's like the negative of the idea, which means we're getting rid of the idea. If the ideas themselves add, then to get rid of ideas means to subtract. Okay, or to get rid of. And in multiplication land, how do you get rid of something you're multiplying by? You divide. So what we're doing here is we're going to be, see this negative here for subtraction turns into division. So this is like we're dividing by 2 3 times. For a division, you always have to start with something, and you always start with 1. So take 1 divided by 2, then divide by 2 again, and then take that and then divide by 2 again. Another way of saying this is simply you have 1, you divide by 2, then if you divide that by 2 again, hey, that's the same thing as just simply thinking, okay, this is 1/2 of something, right? And we're dividing that something by 2 to give us a half. Hey, look, we're just multiplying this half times a half, it's a 4th. So we're taking a half of a half, basically, right? Because dividing by 2 means taking a half. Taking a half of a half, you get a 4th, so it's just 1 over 2 squared, right? But if we did it 3 times, we repeat the process, we'd have 3 2's in the denominator, 2 cubed. So it's like, so this negative basically is talking about exponents in a denominator. All right, so throw 2's in the denominator, that's what we have right there. So we're thinking about ideas, adding ideas together, or subtracting them by dividing, getting rid of things. So for instance, if we had something like this, if we had, let's see, 2 and we divide it by, let's see, maybe 2 to the 4th and maybe like 2 to the 1st. All right, this is the same thing as we'll have 4 factors of 2 on the top, 1 factor of 2 on the bottom. How many factors do I have of 2 now? I mean, you can write this out, but essentially you see that it's going to be 2 cubed. It's 2 to the 4 minus 1. Those exponents subtract very nicely. Okay, so what if we had something like this? 2/3 to the 1/5. What's 1/5 of the idea of having multiplication by 2/3? Well, if we think about it, if we had 1/5 of the idea of multiplying by 2 and 1/5 of the idea of multiplying by 3, What happens if we multiplied this to itself 5 times? You'll notice it's the same thing as like so we can keep on, we could write it out so you can see, but it's going to keep on going. Essentially what we're doing is we're multiplying the denominators together, the numerators together. So really if we did that, shouldn't we get, if we did this 5 times, shouldn't we get a 2 over 3? Well, that tells us that one way of rewriting, remember, really what we're doing is just rewriting things when we have an expression. We're not, really when we have expressions, we're just simplifying or rewriting it. There's no trying to find out what something is. It is what it is. This is what it is. We're just rewriting it. And often in algebra, calculus, and whatever else, that's really what we're doing. We're not saying, what is this? We're just rewriting it in a simpler way, or a way maybe that we can think about for our purposes. So 2 to the 1/5 over 3 to the 1/5 is a way that we could rewrite this 1/5. Basically, it's as this idea right here will distribute to each part of across the division. So exponents themselves right here will distribute across that. Why? Well, think about what's happening here. I mean, when you're thinking about exponents in divisions and multiplications, if they all have the same base, but they have to have the same base, but if they all have the same base, then things would be adding and subtracting. So then what does this gut come in and do? It distributes across that, like multiplication does across addition or division, but it's kind of a little bit different here because it's exponents. Exponents themselves will not distribute over addition like this. This is not equal to a squared plus b squared. Think of it as a FOIL, a plus b, a plus b. There's going to be an inside and outside term. You're going to get 2ab in the middle. So you have to be careful whenever you see exponents. Exponents do not distribute over addition because they do not represent repeated addition. They represent repeated multiplication. Things distribute over what they represent a repetition of often, at least in these cases. So we have a 5th will distribute over the 2 and the 3, or over the division of 2 and 3 in this way. So it can distribute to both parts. Likewise, it can distribute across multiplication, but it cannot distribute across an addition. No exponent can. So people are often, this is a very common mistake, people want to rewrite this, but this is not equal to x plus 2 because this is an exponent. Exponents do not distribute over addition. They do not represent repeated addition. You can look at lots of examples. You plug in 2, 5, 3, 6, whatever. You'll notice these things will be very different. So if all else fails, try something out before you say it's equal to something. It's not black art magic that we're working with. We're just, these are real things. This is a number. This is a number. You can even try different things in and say, oh my goodness, those are not equal. I'm not using real ideas. I'm just using some kind of funny thing that I thought in my mind that this will distribute over. No. Well, what do things mean? This means take 1/2 of the idea of some multiplication. Well, this addition has nothing to do with the multiplication of x squared plus 4. No, it's 1/2 of the idea of multiplication by x squared plus 4. If you want to split up the idea of multiplication by something, you need to know how to factor it. Well, this might not be factorable sometimes. So it will not split, but it can only go across factors, things that are multiplied together. Okay, well, these are just a few ideas with exponents. I hope that was useful. Thanks for watching.